Like your assignment back from yesterday? So the way you do number 9 is you figure out what QS is first. So we have to subtract like backwards, right? So 2 minus 3 is -1. And then -8 minus 4 is -12. I mean, multiplied by 2. Yeah, that's it. Okay? Yep. I mean, yeah. It's state. It's post districts. They are. So what we're going to do now is we're going to actually add vectors together. Yes. No. What we did in the other one was we were adding. Okay. Yes. Yes. But the difference was the ones that we were doing before, we were only figuring out the magnitude. And what we're going to do is we're going to figure out the direction also. Okay? Yeah. Uh-huh. Yep. Yeah. Oh, for the magnitude? No, add the components first and then find the magnitude of them put together. Okay? Both. Yes. So let's say QR came out to be 1, 2. So make that 3, 6, and then add it to whatever the other one was, and then find the magnitude. So you find the magnitude of the final product. Glad you enjoyed it. Okay, so visually, Shelby, Corey, Grace, what's happening, Cole, when I'm adding vectors together? This is important, so I'll make sure everybody's paying attention here. When you're adding vectors together, you do it in the method that's called the, some people call it tip to tail, or you can do tail to head, okay? So you take the end of one vector and put it onto the beginning of the other vector. So these two things right here, U and V, the way that I'm adding those together is I took this arrow right there and put it on the end of that one. The vector that I get as a result of that is the one that starts at the beginning of this one and goes to the end of the other one, okay? And that was a little bit confusing, but here's what I'm talking about. If I want to take this vector right here and add it to this vector right here, remember that vectors have both size and direction. So I have to maintain both of those, okay? So if I was going to add those together, I'm just going to take this one and slide it there so it's on the end of that guy right there. And then the answer that I'm looking for is what I would get is if I started at the first one and I ended at the second one. Okay? Notice that what's awesome about this is that it's math, and so it works no matter how you do it. If I had started like this and you were like, well, why can't I take this vector and put it onto the end of that one, it would come out to be the exact same answer if I did it that way instead. Okay? So it doesn't matter which one goes on to the end of which one. But what you have to remember is the mistake that students make when doing this is you don't add vectors by going like that and then going from here to here. Okay? Yeah, you go the tip of one to the tail of the other one, or the head of one to the tail of the other one. Quiet down. Silencio. Okay? And so that's why they have this little parallelogram here. It doesn't matter whether I go this one and then that one, or if I go this one and then that one. Either way, the thing that I'm going to get is going to be the same. Okay? Yeah, we should. Mm-hmm. I'm sorry. I'm sorry. Boy. Okay, we kind of did this already yesterday. I kind of sprung this at you in some of the questions and then made you sort of figure it out. If you take a vector and you just multiply it by a plain old number, then you are just doubling the size of the vector, all right? If you multiply it by a number smaller than 1, then you're shrinking the size of the vector. If you multiply it by a negative number, then you're also changing the, yeah, you're right. Nice job. No, you're right, but Maggie made a really good, insightful comment last period, and your comment reminded me of that. I was going to give her a dojo point. So, okay, so we did this yesterday, right? I just threw these at you, and then you just figured it out because you're smart kids. Okay, to get a unit vector, which would be a vector that's going in the same direction, but it has a length of 1, you take the vector and divide it by its own magnitude. Okay? Give me a vector, Emma. Give me a vector. Okay, that is super creative. All right? So we're going to call this vector v. Okay? What is the magnitude of that vector? Square root of 5. Okay? So the way, if I wanted to do a unit, yeah, this squared plus this squared, then take the square root. Pythagorean theorem, basically. Okay? This squared plus this squared, then take the square root. Basically the Pythagorean theorem. Okay? This squared plus this squared, then take the square root. Basically the Pythagorean theorem. Okay? Okay, so if I wanted a unit vector that's going in this same direction, the way that I would get that is I would take my original vector that Emma gave me and divide each one of the pieces by the magnitude, which in this case was the square root of 5. So it would be 1 over the square root of 5 and then 2 over the square root of 5. Okay? So if I went to find the magnitude of that vector, this squared is 1/5 plus this squared is 4/5. 1/5 plus 4/5 is 5/5, which is 1, and the square root of 1 is 1. So this vector will have a magnitude of 1. Okay? But since I'm multiplying it by a scalar, I'm just multiplying it by a number, it's still going to be pointing in the same direction as the original vector. It's just going to be a different length. Okay? So that's what this formula is right here. To find a unit vector, take the original vector and divide it by the magnitude of said vector. Okay? No, the answer is 1 square root of 5, comma 2 over the square root of 5. Yeah. Let me see if Desmos, I don't know if they do vectors on Desmos or not. Maybe not. That is not true. I don't think that's true either. Yeah. Oh, okay. If I square this and add them together, it's basically the Pythagorean theorem. So 1 squared is 1, square root of 5 squared is 5, 2 squared is 4, square root of 5 squared is 5. So, okay. Thanks for that. All right. So, yeah. All right. So let's do the same thing. Why don't you guys do the same thing with the vector that is negative 3, comma 2. So find a unit vector, same direction, but it has a magnitude of 1 using that. Okay? Woo! You guys get for your answer here? I'm hoping you got. Okay. Yeah. Okay. Easy peasy, right? Okay. Yep. That's it. Yeah. So unit vector, you divide by the magnitude of the original vector. Okay. Oh, that was me confirming that it had a length of 1. So yes, so if we wanted to confirm that this has a magnitude, a magnitude of 1, I would go this squared is 9 over 13. This squared is 4 over 13. Those things added together are 13 over 13, which is 1. So it does, I mean, these should be underneath square roots, I guess. Unit vector is the original vector divided by its magnitude. Okay, unit vectors are super handy, and so there are 2 special unit vectors that show up all of the time. One is called the vector I, and it is 1, 0. So that would be the vector that is just going 1 unit directly in the x direction. And the other vector is the unit vector j, which is 0, 1. So that would be a vector that is just going up 1 unit in the y direction, okay? And one of the things that's fun about those unit vectors is you can take any vector and rewrite them as a linear combination of those 2 vectors. So for example, the one from the last problem, negative 3, 2. So I can take the vector v equals negative 3, 2, and I could rewrite it as negative 3i plus 2j. Okay? Because negative 3i would be negative 3, 0, 2j would be 0, 2, and if I added those together, I would end up with negative 3, 2. So this is just a method to rewrite those in terms of a more standard unit vector. Okay? Perhaps that will be made clear later. Perhaps not. Yeah, I can. All right, so far we've been spending a tremendous amount of time dealing with the magnitudes of these vectors. We have not touched on the angle situation at all. Are you ready? Because we know from Braden's sharing with us yesterday that vectors have magnitude and direction. So let's talk about how to find that direction, okay? So if I start with this vector right here, this is important to write down. The amount of stuff going in the x direction is the magnitude of v times the cosine of this angle that it makes. And the y component is the magnitude of the vector times the sine of the angle that it makes. And so what that's going to do for us is it's going to break this vector. It's going to take any vector and break it down into 2 separate pieces, one pointing only in the x direction, which is the horizontal component, and then the other one pointing in the y direction, which is the vertical component. And again, I know, like Ben said, why would we want to do this? I'm throwing a lot of weird stuff at you, and I'm asking you to trust me that I'm laying a foundation first for something that we're going to use to fly an airplane later on. Okay? But you got to kind of learn this stuff first. Okay? No, it's right here. Oh, okay. Okay, so yeah. All right, so here we go. Shelby said, are they going to give us the angle? Yes, they are. Let's find the components of the vector v with a direction angle of 115 degrees and a magnitude of 6. This says figure 6.11. I didn't paste that into the drawing here, so if you want to refer that into your from your book, then you sure can. All right, so are you ready? It's going to be crazy. Here it is. Are you ready, Grace? I hope you're winning that game that you're playing. I hope it's worth the time. All right, so this time not only do they give us the angle, but they give us the magnitude. So we don't even have to use the Pythagorean theorem to figure that out. So to figure out the x component, I'm going to go 6 times the cosine of 115 degrees. And to figure out the y component, I'm going to go 6 times the sine of 115 degrees. So that's just calculator work. Anybody got that? Oh. Negative 2.5. And just as they are written. Nope, you just do each one separately, 2 different pieces. And 5.4. Okay, so the reason why this came out to be an x-coordinate that's negative and a y-coordinate that's positive is because, remember, in math class, we start at the positive x-axis and go around counterclockwise. So 115 degrees would be over here. So if I'm going to break this down into the x component, it's going to be in the negative direction. And then the y component is going to still be positive. Okay? All right, Shelby asked a great question. Are they always going to give us the angle? Nope. Sometimes we need to figure out the angle ourselves. Okay? But that's why this is coming immediately after our chapter on trig stuff. So this says find the magnitude and the direction. The magnitude we've done already. The magnitude of that vector would be the square root of 13. Okay? To find the direction, we're going 1, 2, 3, and then we're going 2. I want this angle right there. Any bright ideas how I can find that angle? You're not going to guess. There's no guesswork involved. Anyone? Okay, yeah, basically, so I have a little right triangle here. Okay, I know that this side is 3 because the x was 3. I know that this side is 2. What trigonometric ratio uses those two sides? Sine, cosine, or tangent? Thomas, we've had conversations before about paper airplanes in class. Tangent, right. So the tangent of this angle would be equal to 2 over 3. But since we're trying to find the angle, that means the angle is equal to the inverse tangent of 2 over 3. What is the inverse tangent of 2 over 3? Nope, I know what you're doing there with the inverse, but 34 degrees. Okay, so the magnitude is square root of 13, and the angle is 34 degrees. Okay, and again, you just use the inverse tangent. I don't know if this formula is... Okay, so you should write this down. To find the angle, you take the inverse tangent of y divided by x. So the angle is 34 degrees. That's the angle that the vector makes with the positive x-axis. That's to find the angle. We already did the magnitude. That's the Pythagorean theorem. I can go through that with you again if you would like. You basically just square them, add them together. Now this is the angle, well, it depends on what mode you're in, I guess. If you're in radian mode, it'll give you the angle in radians. Typically, vector math is done in degrees, which is odd. But it is actually, I know it doesn't seem like it, but it does actually have real uses, and most people work in degrees. Yes? Huh? Yeah, I'm done with you.